Now we are seeing expression for longitudinal strain in thin cylindrical shells, nothing but pressure vessels. So here the fluid present in the pressure vessel will apply force in all directions. So if we take force in along length direction, that is suppose along x direction, so this force will produce stress which is nothing but longitudinal stress, and we are taking it with symbol sigma t. And also the force which is acting along the diameter direction or circumferential direction will produce stress that is called hoop stress or circumferential stress, which can be represented by sigma h or sigma c. So here we have to write the expression for longitudinal strain. So let us see how we can write. So we know that from the basic definition of Young's modulus, we know it is stress by strain, and from that if we write strain, that is stress by Young's modulus. So here we require longitudinal strain. So longitudinal strain is nothing but longitudinal stress by Young's modulus, and here to get the actual total longitudinal strain, we are removing this term from this term. So let us see why we have to remove this term from this term to get the total longitudinal strain. So we know that when this stress is acting along the lengthwise direction, that is longitudinal stress is acting along the lengthwise direction, this not only increase the length of the shell, so which is also decrease the length of the shell, and at the same time, so when this circumferential stress is acting, so it is not only increase the diameter of the shell, so it will decrease the length of the shell. So this stress which is acting along the diameter direction is reducing the length of the shell, or it is producing negative strain in the uh, shell. So we have to remove this from this to get the total longitudinal strain. So if you see from the basic definition of Poisson's ratio, so it is lateral strain by longitudinal strain. So if we take this circumferential stress as a primary stress or the primary direction, so this will become a longitudinal. That means the strain in this direction will become longitudinal strain. So here the longitudinal stands for the primary direction. So and if you take this stress, this is the primary stress, and strain in this direction is primary strain or longitudinal strain, and the strain because of this stress along the lengthwise direction will become lateral strain. So if you write from those considerations, so Poisson's ratio 1 by m is equals to lateral strain by longitudinal strain, and the lateral strain is nothing but strain in the length direction because of this circumferential stress. So that is EL, strain in length direction dash. So here why I am writing dash means, so it is the strain in the lengthwise direction because of the stress in the circumferential direction by, so it is a secondary strain or lateral strain by longitudinal strain means strain in diameter direction because of the stress in diameter direction, so which is nothing but EC, circumferential strain. So if you just write the equation for EL dash, that is strain, longitudinal strain because of this circumferential stress, so it is 1 by m into EC, circumferential strain, and this circumferential we can write strain, we can write circumferential stress by Young's modulus, and if we simplify or rearrange the terms, we can write EL dash is sigma c by me. So this EL dash is nothing but, I told it is a strain in the length direction because of the stress, circumferential stress. So this I told that this stress, that is circumferential stress, will decrease the length of the shell, or it will produce negative strain. So that is the this much value. So this much value we have to remove the actual strain which is produced by the uh, longitudinal stress. So such that we have removing this term from this term, to get the total longitudinal strain. So when we write this the same equation once again here, so it is longitudinal strain is equals to sigma t by E minus sigma c by me. So here we know sigma t formula. Longitudinal stress is given by the formula PD by 4T, and circumferential stress and hoop stress is given by the formula PD by 2T. So if you substitute these two here, so sigma T PD by 4T by E is there minus sigma C PD by 2T by ME is there. So if I take PD by 2Te common, so PD by 2Te common from this term and this term, so here I am get 1 by 2 minus PD by 2T E outside, so it is 1 by M. So the longitudinal strain, this also we can write delta L by L. So this longitudinal strain is nothing but PD by 2Te into 1 minus M minus 1 by M. So this is the expression for longitudinal strain in thin cylindrical shells or pressure vessels. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.